Hello everyone, I'm Satya from 2nd MSc Microbiology. In this video, let's discuss about fermentation and types. Fermentation. Fermentation is a metabolic process through which microorganisms convert organic compounds, particularly sugars, into simpler substances such as alcohol, acids and gases under anaerobic or low oxygen conditions. The term fermentation was coined by Louis Pasteur. The science of fermentation called zymology. Types of fermentation. Type 1. Alcoholic fermentation. Alcoholic fermentation is an anaerobic process where yeast and bacteria, namely Saccharomyces cerevisiae and Zymomonas mobilis, convert sugars, mainly glucose, fructose and sucrose, into ethanol and carbon dioxide. Some of the applications of alcoholic fermentation are beer and wine production and production of ethanol as a biofuel. Type 2. Lactic acid fermentation. In this process, lactic acid bacteria, namely Lactococcus lactis and Lactobacillus acidophilus, convert sugars into lactic acid. It occurs in two forms, namely homolactic fermentation that produces only lactic acid and heterolactic fermentation which produces lactic acid along with ethanol and carbon dioxide. Application: yogurt and cheese production. Type 3. Acetic acid fermentation. Acetic acid bacteria, namely Acetobacter acetic and Acetobacter pastorianus, oxidize ethanol into acetic acid in the presence of oxygen. Application: vinegar production. Type 4. Butyric acid fermentation, performed by obligate anaerobic bacteria, particularly Clostridium butyricum and Clostridium acetobutylicum. This process breaks down sugars into butyric acid, hydrogen gas and carbon dioxide. Applications: fermentation and silage, production of butyric acid for industrial uses. Type 5. Propionic acid fermentation, carried out by Propionibacterium species, that is Propionibacterium friedenreichi. This process generates propionic acid, acetic acid and carbon dioxide. Application: Swiss cheese production, which results in characteristic flavors and holds. Type 6. Formic acid fermentation. In formic acid fermentation, the pyruvate is metabolized to formic acid as a primary product, often along with other products such as carbon dioxide, hydrogen and organic acids, by Clostridium butyricum. Application: used as a chemical precursor in leather tanning, textile dyeing and as an antibacterial agent. Type 7. Gluconic acid fermentation. Aspergillus niger and Penicillium chrysogenum are capable of oxidizing the aldehyde groups of glucose to gluconic acid. Application: used to improve dough stability and texture in bread and bakery products. Type 8. Mixed acid fermentation. In this process, bacteria like Escherichia coli produce a variety of organic acids that are lactic acid, acetic acid and formic acid, along with gases like hydrogen and carbon dioxide. Applications: initiates acidification by producing lactic and acetic acids, preserving and enhancing the flavor of fermented vegetables like sauerkraut and pickle, contributes to flavor and preservation in soy sauce and miso. Type 9. Butanidiol fermentation, performed by bacteria such as Enterobacter and Klebsiella. This process produces 2,3-butanidiol along with other byproducts like ethanol, lactic acid and carbon dioxide. Application: industrial production of solvents like butanidiol. Type 10. Hydrogen gas fermentation. Certain anaerobic bacteria like Clostridium acetobutylicum and Clostridium butyricum ferment organic matter to produce hydrogen gas as a byproduct. Application: biohydrogen production. Type 11. Methanogenic fermentation. Methanogens like archaea produce methane gas by converting organic acids, alcohols or hydrogen and carbon dioxide. This is a key step in anaerobic digestion. Application: biogas production. Type 12 malolactic fermentation. This is a secondary fermentation in wine making where malic acid is converted into lactic acid and carbon dioxide, softening the wine's flavor. The lactic acid bacteria are primarily involved in malolactic fermentation. Application: conversion in red and white wines to enhance taste. Thank you for watching.